Alright, let's set it up. Welcome to the Griffith Park train rides. You can come here and ride one of their trains. Should hashtag click on the link below to find sponsorship, to sponsor and fund Ryan's Got Runs running podcast. All right, we're gonna get started. This is about mile 2 for me. Yeah, here we go. Well, I just reached mile 1, so I'm on my second mile, and I did it very casually, under 10 minutes. Mostly downhill, and we're gonna try something. We'll try something new today. I'm gonna try to talk the entire time about everything, most of everything that I think I know about physics, QN physics graphic, right? Post-production. Apparently, oh my goodness, apparently there's other features I can access on YouTube, but in order to upload a video 15 minutes longer, they require my phone number, which is deciduous, deceptive, and just plain evil. But you know, that's a philosophy question topic. We're gonna save that for, I don't know, we might save that for later. You might organically jump in to the virtues of Socrates, right? Some say one of the greatest philosophers that ever lived. I had the pleasure of being turned on to his wisdom by a student of mine from Iran. Beautiful person, beautiful personality. He talked about the Socratic method, the virtues of Socrates, right? The Socratic method essentially is discovering truth using reason through two-way conversation, right? Talking, right? Truth. You can get real philosophical with truth, the nature of reality. What is real? What is truth, right? What do we expect to be true? What do we believe to be true? How does that affect what we see to be true? What we perceive, right? What is the truth? The truth is a combination of many things, right? It's a story. It's a narrative. It has details, many things. Oh my goodness. I've lost my train of thought. Idiom, train of thought. Woo! Hey, look at that squirrel. He's so cute. Alright, so I got the head cam today because I thought the chest cam was giving a little too much harmonic oscillation. I'm like, I don't know why I can't run with my chest being still. Like, why does my chest go back and forth, you know? It seems, I don't know, the physics, the mechanics of movement seem more complicated. And I imagine them to be trying to run with my arms straight, T1000 style, right? Hugging my elbows to my body at all times. Running tip, shoulders back, down, right? Straight posture. Not trying to lean forward, sometimes leaning forward. They say a little bit, you know, you want to move as close to your center of mass as possible, right? To prevent injury, and to promote efficiency, right? Efficient motion. So this is where Newtonian mechanics comes in. If I'm doing this side by side, it's what we call lateral motion, horizontal if you will. I'm trying to go vertical. I'm trying to go in the X direction, and this movement is putting me in the Y direction. But yeah, perpendicular, right, to the direction of motion. So if I want to go this way, straight arms, you know, you're moving along the plane, I guess, plane of existence. All right, so now we're getting back into mathematics, multivariable calculus, planes of existence. So I'm moving in the, say, the Y plane, and this is moving me. I'm still in the Y plane, so it's not like a different plane of motion. It's more just a different direction, right? So it's like this is going left, right, left, right, left, right, or I'm trying to go forward. I'm not trying to go left and right, I'm trying to go back to front, from back to front. So yeah, same plane of motion. Well, I guess depending, if you're thinking about like a plane, like a solid wall, imagine a solid invisible wall this way, cutting through your body, moving forever forward and backward, right? If you were to rotate about the waist axis, whatever that is, rotate about the, I guess, the X axis, the X plane. Yeah. Oh man, I'm so rusty with mathematics, you guys. I'm sorry. This is honestly my first time genuinely thinking about physics, and yeah, tragically maybe 3 years since I got my degree, UC Santa Barbara, dedicated myself to the study of physics, and now learning to prove the purpose of that adventure to myself and my journey moving forward. So here we are. This is beautiful park. I call this the horse trail because I often see horses. You know, this trail seems like it's designed for horses. So, horse trail. Often see horses. How's it going? Got a thumbs up from that guy. Very cool. Always fun to get recognition from fellow runners. It's like we're all out here doing our best, doing our thing. All right. Quantum field theory. Man, what does that mean? Where are we? Not even mile 2 yet. Oh man, I gotta pick up the pace. Oh, yeah. A field. What's a field? There's a lot of theories, belief systems. You know, Deepak Chopra talks about quantum nature of reality, infinite possibilities, infinite potential, right? Thinking about the potential state of, well, in quantum physics, for example, the potential state of an electron, right? And state meaning position, energy, spin, direction, all these things. Where is it going to be? Inside of what time space will it be at a certain point along space-time? Space-time, super connected, right? So first force, the first of the 4 forces discovered of the known working universe was gravity. Gravity. Whew. Beautiful dog. You know, Einstein got a lot of credit for gravity. Shout out to Johannes Kepler, right? astrophysicist, philosopher, magician, back before we had such segregated titles for professionals. Before you could just be all the things. I'm just a person who wants to know and understand the nature of existence and reality. You know, let's try and figure that out. The beauty of golf. Welcome to Harding 18-hole golf course. Hope it captures more beautifully than the chest cam. Oh no. Oh wait, it's been 10 minutes, right? Gotta follow the 15-minute rule with YouTube, so we've only got 5 more minutes of fun for this episode. Tune in next time. What is gravity? The bending of space-time. Physics Professor Makudin, Mr. Makudin, Dr. Makudin. Very fun. I don't know why. I'm not attempting any kind of accent. He had a basic, I don't know, Colorado-ian accent. Yeah, the bending of space and time. What does that mean? What does that mean? What's a gravitational wave? We recently, within my lifetime, I discovered the existence of a gravitational wave, right? Einstein, going back to particle wave duality, right? Einstein's relativity, the study and nature of light, the most fascinating, miraculous phenomena? Grammar question. Pluralization. Particle wave duality. Einstein discovered that not only does light possess this particle wave duality, but in fact everything of the known universe possesses a particle wave duality. We all live in the physical universe, going back to philosophy, duality, right? Light and dark, one particle and antiparticle, symmetry, up and down. Can't have one without the other. Alright, so light moves through space-time, doesn't need a medium to move through, right? A medium is substance. Like our atmosphere on Earth is a medium which sound waves travel through. Sound needs to travel through a medium. That's why they say in space no one can hear you scream. There's no medium through which, you know, back to the invisible glass wall image. Imagine a myriad of glass walls stacked one in front of the other, and imagine that going in 360 directions, 360 degrees of direction in every direction. And if you were to punch through, if you were to hit one of those walls with your fist, like Sub-Zero, like Scorpion breaking through Sub-Zero's ice wall, like Wolverine. Yeah, the X-Men. So that wall is gonna crash into the wall in front of it, and then that wall is gonna crash into the wall in front of it, and then we have what some call the domino effect, right? One into the other, and then the reaction of these collisions of invisible glass walls, right, for the purpose of the visual, creates a wave of energy. This is the direction, this is the position, the representation of a wave. A wave is a probability, a wave of probability. Or going back to quantum particle physics, talking about the electron. First thing, where's the electron? What is an electron? Alright, got a nice smile. It's pretty good. You're a beautiful bird. That was like a hawk or something. Yeah, look at that. That's cool. We got the people seeing if they wave back. Gravity. So there are no, you know, that medium. Water is another example of a medium. Molecules connected to each other, touching each other, right? Creating a network, a field, a web. So gravity has to do with mass, right? Large objects moving. Everything has a gravitational field. And then what's a gravity particle? Everything is a field. Everything is part of the field in this quest for unified field theory, right? Unified field theory. There's a lot of questions and understandings of this situation. It sounded like a good hit. Unified field theory. Stephen Hawking, my favorite physicist. Very tragic when he died. Sir Stephen Hawking devoted his life to the quest, unified field theory, connecting the four forces of the known universe: gravity, strong force, weak force, and electromagnetism. Woo! There's a mouthful. Each of those forces is an entire year of college study, in my experience. Electromagnetism, whew, that was a rough one. Maxwell equations. Yeah, man. So, strong force, weak force, that's particle physics, baby. That's quantum. You gotta understand quantum to understand particle. But you know, you're gonna have to also understand electromagnetism to see the parallels and comparisons. Represent everything that we thought we knew in 1910. Before everything we thought we knew blew up, Max Planck said, hey, what about this stuff? And then boom, the quantum 10. Ooh, the quantum 10. What a powerful subject. Whew. Everything we thought we knew. So essentially, if you want to compare the mathematics, right? Mathematics for, they call it Newtonian mechanics, and the end of more advanced understandings of this mechanics, we had to study Kepler's laws, which gave more precise and exact equations to satisfy the conditions of gravity, elliptical orbits, masses in motion, you know, that kind of stuff. So, I know everybody loves Newton. He's like the most overrated physicist, which is a crude thing to say, I guess. But you know, he did get a lot of credit for stuff that a lot of other people did, not unlike Mr. Thomas Edison. But I don't care to talk about him, because where are we? Almost? Oh no, I think I got past the 15-minute mark.